I have this lathe for 1 year now and I absolutely love it. Before I could use it, of course, I had a lot of work to do. For example, remake the tailstock and do some work on the electrical system. I also had to make some new gears for the gearbox. And now that all this is done, the thing seems to work just fine. Now there's a few little oil leaks, but there is one little test I didn't do yet, and that is how parallel does it cut. Of course I did some testing, you know, taking some cuts and then take measurements, but I think the ultimate test is to make a cylinder, and a smaller cylinder that should fit inside. Not too tight, not too loose, and over the whole length. And to do this test I have a little piece of pipe. Now this is a thick wall, I think it's about 3 mm thickness. And this is the kind of pipe I really like to use to make cylinders for my engine builds. I have a tiny piece of something here, and this could be a piston, but because it is a really short piece, what I'm gonna do is this side or this side I will drill and tap it and then make a little stud in here so I can hold it to turn down the diameter, and these two parts should fit together like an engine. I just cut my little piece of pipe in two. I think this will be better. Now, because in my opinion it is more complicated to adapt a cylinder to a piston than a piston to a cylinder, I will start with making the piston, which means it will be a little bit more complicated because of the flexing of the boring bar. So instead of make it easy, let's make it difficult, well, a little more difficult. Piston. You didn't witness the thread cutting and assembly of the thing because I forgot to press record. So maybe next time. Right, when I measure this thing here, I can make an inner diameter of, on my blackboard, 28 mm. So let's cut this thing at 28. Okay, I admit I was completely lost here in my scale. I hope the camera will pick it up because it's glaring a little bit. To make my balanced cut, you split the total in two and then take two final cuts. And I didn't know what I was doing, but I think I nailed it. 28 point nothing. I was lucky. Part 1 is finished, so I think now it's time for part 2. I'm gonna change boring bar because this one too much stick out in relationship of the thickness. It's a bit a shame because it leaves a very nice finish. This one works perfectly fine. So this one didn't sound good at all. I suppose there was an old bunch of chips stuck between the cutting tool and the part. Nope. Close, but no cigar. And this light pass messed up the surface finish. It's not bad, but it could be better. As you can see, the thing fits, and the fit is okay-ish. There is a tiny bit of play, so for example, to make an engine, this could be perfect. But in here there's a rim. I can hardly feel it, I can hardly see it. And I think this rim is more or less where I switched tools. So my cutting tool here, there was flexion and then a little bit more where I recut. And to make it work, I gave the thing a spring pass, but in the other direction. So instead of cutting from here, I put my tool in, make a spring pass the other direction, and it didn't change a thing. And what's even worse, on the back side, no fit at all. Of course, it could be very easy to cheat, you know, put my little part here back in the machine and then take my polishing woody, and then after, when it fits, show you how good I am. But of course that is not the purpose. I think there's nothing to learn from it. So what is my plan right now? Put back this one in the lathe, take out a 0.5 millimeter more and make sure it is a nice surface finish inside. Which means that this one of course will be too small. But if I take it off and I make a new one out of this little piece of future piston steel, let's try. The thing was singing. But the finish seems to be okay-ish. It looks better than it was before. Right. Let's try to separate these two parts here. Right, let's install the hockey puck that is very well hammered on. And this should be it. That's close. Right, let's cheat a bit. I gave these two parts a very light cleanup with some sandpaper without really changing the dimensions. And now on this side it is a very tight fit, but it fits. And same again, it doesn't go deeper. And if I flip it around, on the other side, it wants to go in, but it doesn't. If I push a little bit harder, it will go in, no problem, but can I get it out again? What I think is happening here on this side is the deformation by the jaws of the chuck of the lathe. So by releasing, instead of being round, it's a little bit weird shaped, but just a tiny bit. I just spent 2 more minutes, not even 2 more minutes, polishing a little bit more this piston-like thing. And now the fit is perfect. It's just that here on this part it fits, but there is a hard spot. And I start wondering, is there maybe some kind of dip in the bed of my lathe? And to figure it out, I would like to do another test. I have here a piece of something that was really hard and I annealed it in my coal fire some time ago. So I'm gonna put it in here, take a cut and take measurements, and then see that if there is a dip, it should show here in the surface. Good. Let's measure. Of course, you're looking at it upside down, but that will do. Here I have 5, 4, 2, 0, -2, -3. Which means I have here a taper. I made the thing, of course, without tail support, and this side is bigger than this side. I did the same test again, without you looking, but I did it. And I took a 1 millimeter cut on exactly the same part, and I wrote the numbers down. So between here and the completely end there is 6 1/100ths of a millimeter difference. And indeed it's tapered and closer to the chuck is going open again. So the idea of the dip in the bed could well be, and that's also more or less what I see in my little pipe here. A tight fit in the beginning, a tight fit at the end, and a little bit more loose in the middle, because the middle part was right here where we use the bed the most. But the good news is that at least the difference on this one here is consistent. I know what I can expect on the little USSR lathe you see in the back there, because the carriage is moving on the bed. It's making weird shapes and you never know when and how and on what position. So I think this is better. Wait, don't go yet. I did a test again with the same cutting tool, but I took a 0.2 millimeter cut. Took the measurements, and over this length, several points, there was a difference of less than 1 1/100th of a millimeter. So I think that's perfect. But because of the carbide with light cuts, doesn't leave a very nice finish, I did it again using my high-speed steel thing here. And the results are the same. Less than 1/100th of difference in diameter. So what I think is happening here is that the big surface here on the bed is more or less okay-ish, and on the other side too, but because of the tool pressure when we take bigger cuts, it's the small side here that take most of the cutting loads in that direction, of course, and also a little bit down, but the downforce is taken by these two bigger surfaces. But I think that less than 1/100th of a millimeter, taking light cuts, I think that's a brilliant result. So it is a good machine, sometimes.